Hello students, in this session we are going to study about balancing redox reactions in basic medium. So before going through the procedure, let us recap the rules once. What are the rules? To balance hydrogens in acidic medium, we have to add H plus ions, and to balance oxygens in acidic medium, to balance oxygens we have to add H2O. Whereas in basic medium, to balance hydrogens we have to add H2O, and to balance oxygens we have to add OH minus. Here another point to be remembered here is to balance one hydrogens we have to add one H plus or one H2O. To balance 4 hydrogens we have to add either 4H plus or 4H2O. So those many entities must be added. Similarly here also, to balance 1 oxygen add 1 H2O, 4 oxygens 4H2O, to balance 5 oxygens 5 OH minus, like that. That point is to be clearly remembered, right? Now let us take one balancing equation in basic medium, right? Suppose we are given with an equation Br2 giving rise to BrO3 minus plus Br minus. So for this reaction, let us find oxidation numbers first, because using oxidation number difference we can assess which is oxidation half and which is reduction half. Here bromine is in 0 oxidation number, here bromine is in plus 5 oxidation number, whereas here bromine is in minus 1 oxidation number. You know the method of finding oxidation numbers, right? Now 0 to plus 5 oxidation, same bromine is changing from 0 to minus 1, that is a reduction. This is such a redox reaction in which same reactant is both oxidized as well as reduced, which is called as disproportionation reaction. What's meant by disproportionation reaction? The redox reaction in which same reactant is both oxidized as well as reduced. The redox reaction in which same reactant is both oxidized as well as reduced. Now, using these oxidation numbers and their difference, we can divide the given equation into oxidation half as well as reduction half. As it is same bromine, we can take 2 bromines at a time, because we can cancel it later by 2. So, one bromine is oxidized, one bromine is reduced. Now, let us divide the given equation. That is step 1. What is step 1? Divide the given equation into oxidation half reaction and reduction half reaction. Divide the given equation into oxidation half reaction and reduction half reaction. So this is 0 to plus 5 oxidation. This is 0 to minus 1 reduction. So one side oxidation half reaction, other side reduction half reaction. So what is oxidation half reaction in this? See, Br2 is oxidized to BrO3 minus. Reduction half reaction is Br2 is reduced to Br minus. This is step 1. What is step 2? What is step 2 in this? Step 2 is balance all main atoms other than oxygen and hydrogen. Except oxygen and hydrogen, rest all to be balanced, right? Here 2 bromines are there, here only 1 bromine is there. We have to make them equal. So to make them equal, let us put 2 here. So Br2 giving rise to 2 moles of BrO3 minus. Same way here also, 2 bromines and 1 bromine. To make them equal, Br2 giving rise to 2 moles of Br minus. So we have equated main atoms other than oxygen and hydrogen. Next step 3 is balance oxygens by adding, in basic medium how do you balance oxygens? By adding OH minus. In basic medium, how do you balance oxidants? By adding OH minus. By adding OH minus on the deficient side. Now see, this side 6 oxidants are there. This side no oxidants. Then to make them equal, what we have to do? Add OH minus. Br2 plus 6 OH minus gives rise to 2 moles of BrO3. When it comes to this one, no oxidants, so no need to balance. Write the same equation as it is. Right? One more thing. The next is the next part is to balance hydrogens by adding H2O. As I said, to balance one hydrogen, you add one H2O. To balance 5 hydrogens, you have to add 5 H2O, right? That point should not be neglected. Now let us count. Already here oxidants are equated. Have you noticed? Here oxidants are equated. Now hydrogens have to be equated. Right, so left side we have 6 hydrogens. Right side, no hydrogens. Right? To make them equal, for 6 hydrogens to make it equal here, add 6 H2O from the rules. Right? It is Br2 plus 6 OH minus giving rise to 2 BrO3 minus plus 6 H2O. Why I added 6 H2O? For equating 6 hydrogens on the right side, I added 6 H2O. But one problem came here. See, already before equating hydrogens, we already equated oxygens, 6 oxygens and 6 oxygens. We already equated oxygens, right? Then while balancing hydrogens by adding H2O, newly 6 oxygens came. Have you noticed? Other than the 6 and 6, newly 6 oxygens came here. How to balance oxygens? Again by adding OH minus. Those 6 oxygens can be balanced by adding 6 OH minus. Now everything will be balanced. You see, 6O plus 6O, 12 oxygens, 6 plus 6, 12 oxygens, 12 hydrogens and 12 hydrogens. See? Understood? Now when it comes to this one, there are no hydrogens, so no need to balance. So what is our next step? We have to balance charges only by adding electrons. We have to balance charges only by adding electrons. See, let us count charges. This 6 minus charges plus 6 minus charges. How many? We have 12 minus charges here, whereas here only 10 minus charges we have. We have only 10 minus charges, right? So left side we have 12 minus charges, right side we have only 2 minus charges. Left side 12 minus charges, right side we have 2 minus charges. So how many more are required? 10 minus charges are to be balanced. So for 10 minus charges, add 10 electrons here. See, Br2 plus 12 OH minus gives rise to 2 moles of BrO3 minus plus 6 H2O plus 10 electrons. When it comes to this one, right side 2 minus charges are there, left side no minus charges. To make them equal, let us add 2 electrons. So here and there, we balanced the charges only by adding electrons. Now our next step is what? Our next step is equate the added electrons. Equate the added electrons using crisscross method. Equate the added electrons using crisscross method. How do you make them equal? Suppose we have added 10 electrons here and 2 electrons here. We can make them equal by multiplying this whole thing with 2 and this whole thing with 10. Right? We can make them equal by multiplying this whole thing with 2 and this whole thing with 10. Means with that number you can multiply here, with this number you can multiply over there. And also we can notice one thing. These 2 and 10 are divisible by 2. You can multiply them with 1 and 5 also. Simple ratio also we can use. Now multiply this whole thing with 1. Br2 plus 12 OH minus giving rise to 2 BrO3 minus plus 6 H2O plus 10 electrons. Right. This I multiplied with 1. That also you multiply with 5 and then write. Multiply that with 5. 5Br2 plus 5 2 is 10 electrons, giving rise to 5 2 is 10 Br minus. 10 Br minus. So we multiplied this with 1, that with 5. Now we got the two equations. Now what is the last step for us? See, to get the equation, what is the last step? Add the two half reactions. Add the two half reactions. This is step 7. Two half reactions. Add the two half reactions. These reactants plus these reactants giving rise to these products plus these products, right? Now, before adding, we can even cancel the number of electrons. 10 electrons and 10 electrons will be cancelled. Now add them. 5Br2 plus 1Br2. 5Br2 plus 1Br2, it is 6Br2 plus 12OH minus. 12OH minus reactants are added, gives rise to 2Bro3 minus plus 2Bro3 minus plus 10Br minus plus 6H2O. 10Br minus plus 6H2O, right? Now you see all the coefficients you can notice 6, 12, 2, 10, 6. They are all divisible by 2, right? Divide them with 2. 3Br2 plus 6OH minus gives rise to Bro3 minus plus 5Br minus plus 3H2O. Now you can see all atoms will be balanced. 6 bromines, 1 plus 5, 6 bromines. 6 oxygens, 3 plus 3, 6 oxygens. 6 hydrogens, 3 to 6 hydrogens. Next, charges. These are 6 minus charges, 1 plus 5, 6 minus charges. Everything is balanced. This is how to balance the redox reaction in basic medium. As I said earlier, this is a PU concept. This method is only for PU. Okay, but for competitive exams, as I told you earlier, we can solve the same question in maximum 20 seconds. I'll give the technique also. Okay, so this is how we can balance it in half reaction method or ion electron method, because we are dividing them into ions and adding electrons finally and then solving. That's why this is called as ion electron method, or also called as half reaction method, right? Now let us discuss one more numerical in this basic medium thing. Okay, right. Now let us discuss one more balancing redox equation in basic medium, which is also a disproportionation reaction. That is, P4 plus OH minus gives rise to PH3 plus H2PO2 minus. So this is just given to specify that the medium is basic. Okay. Now, as it is also a disproportionation reaction, let us find the oxidation numbers. First, it is 0 here, minus 3 here, and this is plus 1 here. Yes, 0, minus 3 and plus 1. See, 0 to minus 3. Now you can say that this is a disproportionation reaction, right? As it is a disproportionation reaction, same reactant is said to be oxidized as well as reduced. I am taking two phosphorus molecules, P4 molecules. We can cancel them as we did in the previous question, right? So one phosphorus is changing from 0 to minus 3, that stands for reduction. Another phosphorus is changing from 0 to plus 1, that stands for oxidation. Increase in oxidation number is oxidation, decrease in oxidation number is reduction. Now using this data, we can divide the given equation into oxidation half as well as reduction half. Now let us divide the given equation into oxidation half and reduction half. What is that? We have oxidation half as P4 giving rise to H2PO2 minus, and reduction half reaction as P4 giving rise to PH3. P4 giving rise to PH3. This is step 1. What is step 1? Divide the given equation into oxidation half and reduction half. You have to write the line notes for PU if it is PU. Then next step is, what is step 2? Balance balance all main atoms. Balance all main atoms other than oxygen and hydrogen. Except oxygen and hydrogen, rest all to be balanced. So here 4 phosphorus are there, here only 1 is there. To make them equal, P4 giving rise to 4 moles of H2PO2 minus. 4 phosphorus, 4 phosphorus. Similarly, here also 4 phosphorus are there, here only 1 is there. To make them equal, P4 giving rise to 4 moles of PH3. So main atoms are balanced. Now our next step is, what is the next step? Balance oxygens by adding, in basic medium, how do you balance oxygens? By adding OH minus on the deficient side, right? Right side 8 oxygens are there, left side no oxygens are there. So to balance them, add 8 OH minus on the left side. Right? Similarly, when it comes to this equation, there are no oxygens, so no need to balance oxygen. P4 gives rise to 4 moles of PH3. In the next steps, if any oxygens are coming, you can balance them with the same rule. No need to worry about that. Now we balance oxygens by adding OH minus. So 8 oxygens, 8 oxygens. No oxygens here. So as per till here we didn't balance any oxygens, right? Now see. Next step is balancing hydrogens. This side 8 hydrogens are there, this side 8 hydrogens. Already they are equal. Step 4 is balancing hydrogens by adding H2O. As for this oxidation half, 8 and 8 hydrogens are already equated. 8 oxygens and 8 oxygens are also equated. We need not worry about hydrogens. So 8 OH minus plus P4 giving rise to 4 moles of H2PO2 minus. When it comes to this side, 12 hydrogens are on the product side, reactant side no hydrogens. For each hydrogen we have to add what? 1 H2O. For 12 hydrogens we have to add 12 H2O. 12 H2O giving rise to 4 moles of PH3. Now you got a problem here. While balancing hydrogens, we have added newly 12 oxygens which are not there on that side. So 12 oxygens can be balanced by adding 12 OH minus. Now you see 24 hydrogens, 12 plus 12, 24 hydrogens. 12 oxygens, 12 oxygens, everything is balanced. Right? Now the next part is balance charges by adding electrons. Balance charges by adding electrons. Balance charges by adding electrons. So how do you know how to count the charges? 8 minus charges, here 4 minus charges. Still 4 minus charges more are required on the product side. So 8 OH minus plus P4 giving rise to 4 moles of H2PO2 minus plus 4 electrons. 4 minus charges plus 4 minus charges. 8 minus charges, 8 minus charges. Right? Next, when it comes to this one, here 12 minus charges are there on the product side, reactant side no minus charges are there. So let us add 12 minus charges here. 12 H2O plus 12 minus charges giving rise to 4 moles of PH3 plus 12 OH minus. So now we have balanced the charges in both the reactions by adding electrons. What is our next step? Equate the added electrons. Equate the added electrons. Equate the added electrons by adding by using crisscross method. By using crisscross method. Right? We did in the previous questions. How? Here number of electrons are 4. Here number of electrons are 12. With this number you have to multiply that. With that number you have to multiply this. So multiply this with 12, that with 4. Instead you can take their simple ratio also. 4 and 12 are divisible by 4, right? So you can multiply this with 1, you can multiply this with 3. Understood? Now let us multiply these equations with the opposite number of electrons using crisscross method. so that we can equate the number of electrons. How? See, multiply this with 3, multiply this equation with 3. 24 OH minus plus 3P4 giving rise to 4 3s are 12. 12 H2PO2 minus plus 4 3s 12 electrons. Next, multiply that with 1 means take it as it is. P4 plus 12 H2O plus 12 electrons giving rise to 4 moles of PH3 plus 12 OH minus. Now, we equated electrons using crisscross method. 12 electrons, 12 electrons, which can be cancelled. Now, what is our next step and final step in any numerical? Add the two half reactions. Add the two half reactions. Now, add them and see 3P4 plus P4. 3P4 plus P4. How many? 4P4. After adding, we are getting 4P4. See, 4P4. P4 plus 3P4. 4P4 plus 24 OH minus plus 12 H2O plus 12 H2O giving rise to 12 H2PO2 minus plus 4 PH3 plus 12 OH minus. Still there are something to cancel. See, here 24 OH minus, there 12 OH minus. 12 and these many 12 will be cancelled out of this. And one more is there. This is divisible by 4. 4 and 4 and this one. So all coefficients are divisible by 4. Divide them with 4. Now final equation will be P4 plus 3OH minus plus 3H2O gives rise to 3H2PO2 minus plus PH3. Now you see all atoms will be balanced. You can count it now. 4 phosphorus atoms, 3 plus 1, 4 phosphorus atoms. 3 plus 3, 6 oxygens here. 3 2s, 6 oxygens. 3 plus 6, 9 hydrogens on the left side. 6 plus 3, 9 hydrogens. Right? All atoms are balanced. 3 negative charges, 3 negative charges. All atoms are balanced. This is how we can balance the redox reaction in basic medium following these steps. Okay. So we'll continue the next session with another equation for balancing redox reactions, right? Let us balance this equation in acidic medium, right? So here, this is chromate is oxidizing iodide to iodine, right? So in chromate, it is chromium is in plus x minus 8 is equals to minus 2, x is equal to plus 6. From plus 6, chromium is reduced to plus 3. Similarly, iodine is changing from minus 1 to 0. So this is oxidation, whereas this is reduction. So in that way, we have to divide them into oxidation half and reduction half. Now, we have to make it into two halves. One is oxidation half reaction and other one is a reduction half reaction. Oxidation half reaction is I minus is oxidized to iodine. Reduction half is chromate CrO4 minus 2 is reduced to Cr plus 3. Right? Now, this is dividing the given equation into oxidation half and reduction half. What is step 2? Step 2, we have to write the notes without fail. You see. So, step 2 is balancing all main atoms. Balancing all main atoms other than oxygen and hydrogen. Balancing all main atoms other than oxygen and hydrogen. So here two iodines are there. So let us make 2 here also. So coefficient you make it 2. Iodines are balanced. Here one chromium and one chromium. Already chromiums are equated. Now what is next step? Step 3. Balance oxygens. It is an acidic medium. So to balance oxygens we have to add H2O. Balance oxygens by adding H2O. Right? There are no oxygens left and right side here. So this one will be as it is. 2I minus gives rise to I2. Whereas here 4 oxygens are there on the left side and when it comes to the product side no oxygens. So to balance 4 oxygens add 4 H2O. Oxygens are equated. Next step is balancing hydrogens by adding, in acidic medium, how do you balance hydrogens? By adding H plus ions on the deficient side. Here and there, no hydrogens, so we need not balance for the oxidation half reaction. Whereas for reduction half reaction, this side 8 hydrogens are there, left side no hydrogens are there. So to balance 8 hydrogens, we have to add 8H plus, giving rise to Cr plus 3 plus 4H2O. Right? Now hydrogens are balanced. Step 5 is balance charges only by adding electrons. Balance charges only by adding electrons. So left side we have 2 minus charges, right side no minus charges. So charges can be balanced by adding 2 electrons on the product side, 2 minus and 2 minus. When it comes to this side, see 8 plus charges and 2 minus charges. Left side 6 plus charges were left. Product side only 3 plus charges were left. How do you make them equal? Left side 6 plus charges were left. Out of 8 plus charges, 2 are cancelled. So 6 plus here, 3 plus there. We can equate them by cancelling 3 plus, which will be done by adding electrons. See 3 electrons. CrO4 minus 2 plus 8H plus 3 electrons, giving rise to Cr plus 3 plus 4H2O. Have you followed this? Now you count the charges. 2 and 3, 5 minus charges and 8 plus charges. 5 minus charges and 8 plus charges. 3 plus charges were left and 3 plus charges were left. They are equated. Now our next step is equate. Equate the added electrons using crisscross method. Using crisscross method. How do you make them equal? With this 2, you multiply this whole equation. With this 3, you multiply this whole equation. 2 and 3. Now, let us multiply them using crisscross method. So, I think you are copying the lines. Now, if you multiply this with the 3, 6i minus, giving rise to 3i2. If you multiply that with 2, there plus 6 electrons, of course. If you multiply that with 2, it is 2 moles of CrO4 minus 2 plus 16H plus, giving rise to plus 3 electrons are also there, plus 6 electrons multiplied with 2, giving rise to 2 moles of Cr plus 3 plus 4, 8 moles of H2O. 8 moles of H2O. Now we have equated electrons here and there, and step 7 is add the 2 half reactions. Add the 2 half reactions. Simply before adding, we can cancel some common things. Opposite side electrons are there, we can cancel them, and anything else to cancel, nothing. See, now if you add them, 6i minus plus 2 moles of CrO4 minus 2 plus 16H plus, giving rise to 3i2 plus 2 moles of Cr plus 3 plus 8H2O. Now you can count all atoms, everything will be balanced. 6 iodines, 2 chromiums, 2 chromiums, and 8 oxygens, 8 oxygens, 16 hydrogens, 16 hydrogens. Charges also, product side 6 plus charges we have, whereas here 6 plus 10, 6 plus 4, 10 minus charges and 16 plus charges. 10 minus charges and 16 plus charges, 6 plus charges, 6 plus charges. Everything is balanced. So this is how we can balance redox reactions. I'm going to send homework to you about these balancing techniques. So every one of you must and should solve these equations in both acidic and basic medium without fail, right?